Assalamualaikum warahmatullahi wabarakatuh and good morning. So next exercise is exercise number 3, which is the analysis of a portal frame, 2D portal frame. So this is the layout of the structure, 2 bay portal frame. Let's study the geometry of the structure first. The length of the first bay is 7.5 meters. The height here is 3.5 for this column, and for this highest point is about 5 meters with respect to the ground level. And for the second bay, the length of the bay is 4.5 meters. So total length is 12 meters. And we are going to apply UDL to these rafters and also beam member. For beam member, here we are going to apply normal load, but for this one, for this rafter, I am going to apply load on projection line. Okay, because this is very common when you do analysis or design of a steel structure, especially for the inclined member like this. Normally we apply load based on projection length. Instead of global direction, we apply based on projection length. Okay, so go to staadpro. Let's click the staadpro to start the staadpro. And for this structure, of course, you need to select plane because this one is 2D. And then for the file name here, you can type, let's say, exercise number 3. Exercise number 3. Okay, and just save the file into this folder, the default folder. For the title, you can type anything because this one is just common. You can type anything. The staadpro doesn't recognize whatever you type here. And maintain the unit, meter for length and kilonewton for force. So go to next. Then stay on at beam because we are going to draw lines. Go to finish and change the view to 2D view instead of isometric view. Much easier for you to model the structure in 2D, okay, rather than 3D environment. So since the total length of the structure is 12 meters, 7.5 meters for the first bay, 4.5 meters for the second bay, and the incremental value is 0.5. Therefore, you need to adjust the grid spacing in X and Y to 0.5, not 1. So you need to adjust here 0.5 for both direction, 0.5 for both X and Y direction. And therefore you need to adjust the grid number from 10 to 24 in this case. Okay, you need to adjust to 24. And then for Y, I think 10 is enough because the height, the maximum height of the structure is 5 meters. Okay, so I think that's it. So after you adjust the grid number and also the grid spacing, then you can draw the line to represent the structure. Click this button to start draw the line. So let's say this one our starting point. Next point is here. So of course you can in this case you cannot stop at this. You see that here is 7.5 for the first bay. You need to stop at 3.75. So you cannot, your cursor cannot stop at 3.75 here. Okay, cannot stop at 3.75. So doesn't matter. You just continue this to this line, and then this line. So next I'm going to click this point, but I don't want this line to be created. So therefore again you need to hold control button and click this point. So we don't have a line here, we have a point only, and then click this. When you click this point, the staadpro will divide this line into 2 at this position. Okay, and Now you can stop. Okay, you see that here you have two lines here, and now what you need to do is to introduce a midpoint here. Okay, just follow the same procedure as we did in the previous example. Insert node, add midpoint, click OK. Now we have this point or midpoint. What you need to do, you need to bring this point up of another 1.5 meters. Okay, so let's select this point, change your cursor, select this point, and right mouse, go to move. So in Y direction, you need to add another 1.5 meters, 1.5 meters, then click OK to move this point from this level to this level. Okay, now we have the shape of the structure. You can remove or hide the grid system from the screen. Click this icon. Okay, now next step is to prepare section properties. So for all columns, I am going to use UC section. For all beam and rafter members, I am going to use UB section. So go to General on your left side here, stay on Property, get the data from database, get the section from database, go to British, click OK, and let's say you want to select UB first, universal beam, select any section. Let's say I'm going to select 406, 140, any section, and then add, and then close, select all these three members, rafter members and beam member, assign, then click yes, go to database again, go to British, click OK. This time I'm going to select UC shape. For column, select any section, let's say 305, 118, add, close. So this time you need to select all columns, assign, then yes. So if you want to see whether we have prepared or assigned to the correct line or not, you can get the solid view, right mouse, go to structure diagram, go to full section, and then click OK. So here you can check whether you have assigned to the correct line or not. So this is the full section. Of course, you can rotate this structure. Okay, you can rotate, or you can get isometric view like this to confirm that this one is UC section, this one is UB. If you look at to this structure, so you can move this diagram using this pen zoom icon. Okay, you see that for column here, the dimension or the depth of the column and also the width of the column is almost same. But for UB section here, the depth is longer compared to the width of the beam. So that's the difference between UB and UC section. Okay, now change back to 2D view, and to me during modeling I prefer to show the wireframe view only. So change back to wireframe view, go to structure diagram, just put none here, then click OK. And if you want to switch off this one, you just click this icon again. Okay, next I'm going to apply support to this structure. Go to support, go to create. Let's say we prepare fixed support to all foundation. Select this support, and then select all these 3 points at the base, assign yes. So meaning that we apply fixed support to all foundation. Okay, and then next, if you look at to this diagram, we have a bullet here, small bullet here. Okay, in construction, suppose that you want to have, remember that if you to read this structure as a frame structure or beam structure, all connections are assumed to be rigid. So this between this column and this rafter is rigidly connected between this member and this member by means of sufficient number of bolts, or you put welding all around, you put many bolts and so on. So by doing that, you can have a rigid connection between this rafter member and this column member. So by default, the staadpro will assume that all connection here, this point, this point, this point is rigid. Sometime you need to, let's say, between this rafter and this column is rigidly connected, but between this beam and this joint is simple connection. Okay, so if you want to do that in staadpro, what you need to do, you need to release the moment between this beam and this connection. So meaning that between this rafter and this column is rigid connection, but between this rafter column connection and this beam is simple connection, meaning that this point can rotate freely in Z direction. So in order to release moment here, you need to introduce a hinge. So this is a symbol for hinge. Okay, so if you want to release the moment, in other words, you want to have a simple connection. For example, if you put this beam resting on a simple bracket to this column, meaning that you can introduce a hinge here. Okay, how to introduce hinge in staadpro? So just select this line, this beam, select this beam, and of course you need to determine which one is your starting node, which one is your ending node, by putting cursor on this line, meaning that this one is your starting node, this one is your ending node for this line. So I'm going to put a prepare hinge at starting node. Okay, so after you select this line, on your left side here, there is a button called spec, means specification. Go to this button, and on your right side here, go to beam, and then the staadpro will ask you whether you want to put the hinge at starting point or ending point. Okay, in this case I am going to put at starting point. So if you want to put at both ends, so you need to do it one by one. After you prepare hinge at starting point, then after that, after finish, you go back to this command again, then you select end. Okay, now so remember that when you put start here, the staadpro will ask you what kind of degree of freedom that you want to release. Is it movement or rotation here? So in this case, I want to release the rotation only, MZ, so that there is no moment between this beam and this connection. You will find that there is no moment. Later, when you draw bending moment diagram for this frame, you will find that bending moment diagram for this beam at this connection is 0. But you have moment for this rafter at this point, and also column, you got moment also for this column at this point, except this beam. Okay, and then add, and then assign. Yes, so you have a bullet here to show that we have released the moment at this point. Okay, next I'm going to apply load to this structure. So on your left side here, go to load. Let's say we have one load case only, because our aim for this exercise is to show you how to analyze a frame structure. And click OK, and go to member load, because I am going to apply load here. Member load, let's say the value is negative 22, and then leave it blank for D1, D2 and D3, because I want to apply for full length, and the direction is global Y, and then add, and then assign. And okay, now do the same thing for the rafters, for rafter members. Go to member, put the same value, which is negative 22, but this time I'm going to select PY. So be careful here, because this time I want to change the direction of the load, which is PY, which is projection length. Instead of global direction, I want to apply based on projection length of this rafter. So this is the length, the actual length of the rafter. So the projection length, if you get the view from top or from bottom, the projection length of this member is from here to here. Okay, so I will get the dimension after this. Then you can see the meaning of projection length clearly. Okay, then add. Okay, now just apply to this rafter. These are two rafters. Assign. Yes. Okay, now if you look at to this load properly, okay, this load on beam, this load on rafters. Okay, so let's look at to this load. Just now we apply the same load values, 22 for both beam and rafter members. Why this one is slightly higher compared to this? Okay, now just to confirm about the value, whether you have entered the correct value, you can ask the staadpro to plot the value on your screen. So again, right mouse, label, load, label, load values. Tick this one, load values. Click OK. You see here, the load that we apply to this beam is 22 kilonewton per meter. It's there. You see that? It's printed here. But for rafter member here, the value that we entered just now is 22. But why this value is 20.426? Why the staadpro give this value and not 22? Okay, the reason is that the load that we applied just now based on projection length, but the load that you see on this diagram based on actual length. Okay, let's see the length of this member. Just to confirm, from here to here is 7.5. So half of this is 3.75, meaning that for this rafter member, the actual length is 4.04. This is the actual length of this rafter member. But the projection length is half of this, which is from here to here, which is 3.75. Okay, now, just now we apply this load 22 based on this length. So 22 kilonewton per meter times this length, okay, should be equal to, let's say this load, let's say you don't know the value, this load, let's say W times 4.04. Total load should be same. Doesn't matter whether you apply based on actual length or projection length. So if you apply based on projection length, the length is slightly shorter than this. And therefore, in order to have equivalent load, this load should be slightly smaller compared to this value 22. So that when you multiply 22, this value, okay, on this projection length, which is 3.75, should be similar to 20.426 times 4.04. That's why you got this value. Remember that the total load should be same. Just a matter on the direction of the load that we apply just now is different direction. Okay, So now you have a complete structure. You can run the structure now. Analysis print, add, close, analyze, run, save, done. You can remove node to node distance because sometimes it means disturb your view. To me, before I plot the shear force bending moment diagram or show the deformed shape, I want to have a clean picture like this. Okay, I want to have a clean picture like this. Okay, let's plot let's say the axial force diagram. So it's too big. You can adjust the scale for the axial force diagram, make it smaller. So from this diagram, it's very clear that all members are in compression, shown by the red color here, which is true because you apply vertical load to this rafter and beam. Therefore, all this column, this rafter and beam member are in compression. And then for the shear force diagram, this is the shear force diagram. Okay, you can get the value as we did in the previous example. Fz, of course, we don't have Fz because we apply load in XY plane only. Torsional moment we don't have because we don't have load in Z direction, and we don't have also My, but we can have Mz. You see that? Look at to this bending moment diagram. Since this one is fixed support, of course you have moment here. This ordinate indicates the moment at the bottom part of the column. This one is the moment at the top part of the column. This moment belong to this rafter at this point, and this moment belong to this rafter at this point. Okay, when come to this point, if you look at properly to this diagram, you will find that you don't have moment for this beam at this point. Only at this connection, exactly at this connection, because we have released the moment due to simple connection that you construct during construction. Okay, but you have moment here for rafter and moment here, this orient for column, because between this rafter and this column is rigidly connected. That's the reason why you have moment here for rafter and moment here for column, and we don't have moment here for beam. Okay, and if you want to see the deformed shape of the structure, just click this one and make it bigger, adjust the scale for the displacement. Okay, so after you agree with the diagram, then you can stop pressing the lower button. So this is the deformed shape of the structure. So I think that's the purpose of this analysis in exercise number 3 is to show you how to apply load based on projection line, and also how to introduce a hinge. That's the aim. So there are 2 things that you can learn from the exercise, which is load that you apply based on projection length, and also how to introduce hinge in case that you need to release some degree of freedom in your structure. Okay, I think that's it. Thank you.